Okay, so your test is over 4, 4, 4, 5, 4, 6, and then 5.1. 4, 4, 4, 5, and 4, 6 is pretty much all the same thing. It's factoring completely, using GCF, that P over Q, all that stuff. Where some of you made mistakes on your quiz is you didn't factor completely, or you factored but didn't solve, you know, that sort of thing. So you've got to pay attention to what the directions say. But if you have something like this, do you guys see an equal sign here? No. So I'm not looking for what x equals. I'm looking for everything to be fully factored. The way that we do that, what's the first thing we look for when we're factoring? GCF. Always, no matter how many terms, always look for the GCF. Then if it doesn't factor out anything GCF, then we look to see if it's the difference of perfect squares, the difference of perfect cubes. You guys remember the perfect cube pattern? A plus B, and then A squared minus AB plus B squared versus A minus B, and then our A squared plus AB plus B squared. That's when the first term is cubed, the second term is cubed. If there's a minus sign in the front, this is the pattern you use. If there's a plus sign in the front, this is the pattern you use, right? That's important. But if you have something like 49, I just randomly picked 49. I have 2x squared minus x minus 28. I am not looking to see what x equals. I just want to factor it. So the first thing we look for is a GCF. Is there one? No. So I say, all right, it's a trinomial. So you say A times C. What's 2 times negative 28? Anybody? Okay, negative 56. So I need factors of negative 56 that multiply to give me negative 56, but add to give me a negative 1. What would that be? $56. What's going to give me 56? 1 and 56, 2 and 28. Negative 8, positive 7. Good. Now look how I do this. I might do this differently than you guys did, which is fine. But my A term here is not 1. So I'm going to take this A term and divide both of these factors by it. What is 8 divided by 2? So I have x minus 4 here. Does 7 divide by 2 nice and pretty? No, so then 2 is going to come out here and become my coefficient. If you guys don't factor, this is called when A is not 1. If you don't factor that way, that's fine. Do it how you're used to doing it. That's just how I do it. Is this fully factored now? Yes, there's no difference of squares left in it. There's no GCF, nothing. But it says to factor fully. It does not say to solve, so you would leave it just like this. You guys understand that? Yes? All right, another.
A method that my friend taught me for the AP was sub method. Like the first sign is so as stays the same, and then the second sign is opposite.
Okay.
And then the last sign is always positive. So.
Perfect. There you go. Anything, you guys. There's a million tricks. I encourage you to work smarter, not harder. And there's 500 different ways to get to the correct answer, which is fine as long as mathematically it makes sense. The question I wanted to bring to your attention is something like this. How is this one? Oh, sorry, Gigi, what?
For the last
You show me your thought process, that's fine. How is this different? What do you guys see in this group of questions? There's an equal sign. That means you need to go one step further. You still need to use GCF, difference of squares, blah, 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 blah. But you've got to solve. We want to know what x equals. So in this case, we have 2x squared plus x minus 21 equals 0. Yeah? All right, GCF? No? So we're going to multiply A times C. What is 2 times negative 21? Negative 42. What are the factors of negative 42 that are going to multiply to give me negative 42 and add to give me a positive 1? X plus 7, x minus 6. Okay. Now, since my A term is not 1, I'm going to divide both of these by my A term. Okay, so does 7 divide by 2 nice and pretty? No, that's going to become my coefficient, so 2x plus 7. 6 divided by 2, yes? So x minus 3. And then we go one step further, guys. What does x equal? You take each parenthesis and set it equal to what? There you go. So if I move 7 to the other side, I have 2x equals negative 7, and divide by 2, so x equals negative 7 over 2. And then I move 3 to the other side, so x equals 3. How many answers did I know at the very beginning I was going to have? 2. Remember, the highest exponent tells you how many answers. If you pulled out an x, and there was an x out in front, you have to set that equal to 0 as well. That's an additional 0, so make sure you guys are paying attention to that. All right, let's look at something like here. Again, this looks like the same kind of question. It tells you to find what? All the zeros. Does it say just the real ones? No, it says to find all of them. So if I look at just 72, I just randomly picked this one. I have x cubed minus 13x squared plus 23x minus 11. What is my highest exponent? 3. So how many answers am I going to have? 3. All right, remind yourself of that. So I say, okay, first thing, is there a GCF? No. Is it going to help me if I group? No. So if all else fails, what do I do? P over Q. Good. What? It's the plus or minus the factors of the last term. So what gives me 11? 1 and 11. So we're just going to do repeated synthetic division. So I'm going to try 1. Remember, every exponent needs to be accounted for. So I have 1, negative 13, 23, and negative 11, right? Bring down your 1. 1 times 1 is 1. Negative 13 and 1 is, God bless you. Negative 12 times 1 is negative 12. What's 23 minus 12? What's 11 times? Oh, man. We lucked out here, didn't we? What did we find? What did we discover? One of my zeros is x equals 1. If it doesn't work, do we just give up? No, you try the next one. So what am I left over with here? X squared minus 12x plus 11 equals 0. Now you're at the stage where it's a quadratic. I know it's a quadratic because your highest exponent is a 2, right? Okay. So now you say, okay, should I just do the quadratic formula? You could. But I would first say, let me see if I can factor this. Are there factors of positive 11 that multiply to give me 11, but add to give me a negative 12? Negative 11 and negative 1. So I have 2 more zeros that I found. When I set each piece of those equal to 0, I get x equals 1 and x equals 11. Let's talk about our answers. How many answers do I have? 3, God bless you. Tell me about them. Are they real, imaginary, what? They're all real. What do you notice about them? There is multiplicity. I have x equals 1 how many times? 2 times. Very good. So what does that mean for the graph? What happens at x equals 1 at this graph? Does it touch and turn or does it go through? It touches and turns. When you have multiplicity an even number of times, it's going to bounce off. It's going to touch and turn. Which brings me to these questions. You guys are going to have a question. I'm telling you right now, you're having a question on your test that says, describe the end behaviors. You guys, it's going to be a free response. You tell me, and I'll show you exactly how I want it answered. And then there's going to be one that says, hey, here is this function, match the graph. And some of you are like, I don't know what this graph looks like. You can determine what the graph looks like based upon the characteristics, whether it's odd or even, direction of the arrows, that sort of thing. So let's look at this. I'm describing the end behavior and then what's happening at the zeros. I'm not asking for the zeros here. I'm just tell me what's going on. So the first thing I look at is the highest exponent. How many answers should I have? 3. Okay, is that number odd or even? It's odd. So the ends of your graph are going to resemble a positive line. It's not a line, but the ends will. If it was negative, which way would the arrows be going? The opposite direction, right? So when you talk about the end behaviors, this is how I want you guys to write it. You always read a book from left to right. So we talk about our graph from left to right. What is the graph doing on the left-hand side here? Is it rising or falling? So it's falling left. And what? Rising where? Perfect. Falling left, rising right. Everybody with me? All right, now it says, well, what's going on? What's happening at the ends of the graph? I have 3 zeros. What's happening at the ends of the graph? Well, how do I know what's happening? I need to find the zeros. So I look for the GCF. Is there one? No. Can I group? If I group, I take out x squared from the first group. I'm left with x minus 9. I can't. If I take out a 2, that's not going to leave me with x minus 9. So I have to do what? P over Q. 1, 2, 3, and 6. Start with 1. Bring down your 1. 1 times 1 is 1. Negative 9 and 1 is negative 8. Negative 8 and 1 is negative 8. 2 and negative 8 is negative 6, right? Negative 6 and 1, so I get 0 here. So what'd you just find? X equals 1. Perfect. So what's left over? This is x squared minus 8x, yeah? Minus 6 equals 0. So I'm at a quadratic. What do I do at this point? All right, let's try to factor it. What multiplies to give me 6? That'll multiply to give me 6, but add to give me negative 8.
Is it like something 4 and 2?
If it was 8 at the end and 6 in the middle, it'd be 4 and 2. But is this one going to factor pretty? If it doesn't factor pretty, then what do we have to do? The quadratic. So this is my A, my B, and my C. So I have a negative 8, plus minus negative 8 squared minus 4 times 1 times negative 6, all over 2 times 1, right? So as we simplify this, a negative gives me 8, plus or minus, what's 8 squared? 64. And then a negative times a negative is a, so plus 24 equals 2. So I have 8 plus or minus, what's 64 and 24? 88 over 2. All right, and then we would continue to simplify 88. I'm not going to keep going because I want to make sure that we see everything. But at the end here, you're going to get an answer that's plus or minus, correct? So you're not going to have multiplicity here. So what would happen at the x-axis? It would go through. So what you guys need to do when you have a question that says find the graph that matches, what you need to do is figure out what the ends are looking like, what direction they're going in, then eliminate answer choices. Find the zeros and say, okay, it should go through these points and bounce off of these, and then you can find your answer. Let's talk about the end behavior here. What's my end behavior here? What's the highest exponent? 4, so it's an even. That means the direction of the arrows is going to be the same. They're either both up or both down. How do I know what this one is? They're both down. How do you know they're both down? Because it's negative. So your end behaviors would be falling left and what? Falling on the right. Good. That's all you have to write. You don't have to write anything crazy. Now, how do you find the zeros? What would be the first thing we'd have to do? What do we always look for first? GCF. What can I take out of negative x to the fourth, negative 5x cubed, minus 3x squared plus 9x? They all have an x. I'm going to take out a negative one, because anything that leads with a negative, we want to get rid of it. And then I'm left with x cubed plus 5x squared plus 3x plus 9. God bless you. And then we continue solving, right? If we can't solve it by grouping or anything like that, we do our P over Q and we get moving. You guys okay? Everybody all right? All right. I just want to make sure you see every type of question. All right, then we go to stuff like this. What are they asking me in number 3? This is from 5.1. What are they asking me in this question? The fifth root of what number? Negative 243. First of all, guys, is that possible? Can you take the odd root of a negative number? What's the cube root of negative 8? What number times itself 3 times gives you negative 8? Negative 2. Can you take the odd root of a negative number? Yes. Can you take the even root of a negative number? No. What's the square root of negative 4? Imaginary, right? So all this question is asking is what number times itself 5 times gives me 243. And I know it's going to be negative. So you guys are like, I don't have a calculator. That's okay. Start off small. Does 2 go into 243? No. Just 3. How do we know? What's that little rule I showed you? Add. What's 2 plus 4? 6 plus 3 is? That means if 3 goes into 9, then 3 is going to go into this. So I put 3. And then 3 goes into 24 8 times. And 3 goes into 1, right? So now, is this a little more manageable? Is this a little easier for us to look at? Hi. This a little more manageable? Yes? How can I break down 81 a little bit? 9 and 9? Okay, perfect. Can I break that down a little more? 3 and 3 and 3 and 3? Good. Can you guys now see what the fifth root of 243 is? Remember, Ms. Carver says, how many of a kind do we need? How many of a kind do we need? 5. Good. So do I have 5 of a kind? Very good. So what's my answer here? Negative 3. Good. All right. If the number... See. All right. So now let's look. Let's look at another one. What does this question say? Okay. I know you guys don't know how to articulate it, but you know what it's trying to say. What's going on here? Okay, we need to write it as 1 over, right? 256 to the 5/4. Good. Now, what does to the 5/4 power mean? Remember, guys, what does this fourth do? It becomes the index. So I have 1 over the 4th root of 256 times to the 5th power, right? Now, again, I told you this the other day. You can do either one first. You can raise 256 to the 5th power. You could say 256 times 256 times 256 times 256, all in your head. And then find out what number multiplies, right, the 4th root. Or you can do it the other way. What is the 4th root of 256? Well, I don't know off the top of my head, so do we need to break it down? You want to guess and check? What do we want to do? I know it's not 2, right? Because 2 times 2 times 2 times 2 is not 256. It's not 3. We just had 3. What do you think it might be? What about 4? Let's try 4. Sometimes guessing and checking works a little bit. What's 4 times 4? 16, all right. Times 4? 64. Times 4 is what? 256. So this is really 1 over 4 to what? The 5th power. So all you would be doing here is multiplying 256 times 4 again. Understand, I'm not going to go through all the multiplying behind it, but understand what this negative means. It means, hey, put me in a denominator. What the root means, if you have a fraction, if you have 5 over 4th, this is your index. That's the number, that's the root you're looking for. Everybody with me on that? Okay. How would I solve? You guys have got to, God bless you, you're going to have some solving ones. How do I solve? What am I trying to get by itself first? Okay, not subtract. You're all right, don't apologize. We're going to divide. So I have x to the 4th equals 10, okay? How do I get x by itself? I don't want x to the 4th, I want x. I'm going to take the 4th root. I agree. So I have x equals, first of all, guys, if I'm taking an even root, what goes in front of my answer? Plus or minus, perfect. And do we know what the 4th root of 10 is? Do you know what number times itself 4 times gives you 10? No, so just leave it. That's fine. What about here? X cubed. What am I doing? I have x cubed equals, if I minus 17 here, what do I get? 40, okay. Again, we're in the same situation. Do we know what number times itself 3 times gives us 40? No. But if I take the cube root here, I get x equals, do I have to put a plus or minus? No, because it's an odd. Good. Very good. That's basically the same thing. All right, and you're gonna have two. I know for a fact there's two multiple choice that is something like this. I just want to remind you how to do it. Something like that. It says, hey, write the polynomial for me. What do we need to remember in a case like this? What are my zeros that they gave me? X equals what? 4. What else? X equals 3 plus I, and X equals 3 minus I. Good. And then what do? I work backwards. I put them in parentheses. So X minus 4, X minus 3 minus I, X minus 3 plus I, and I FOIL. Yeah? Yes, sir. Sure. What about if you had this as a root? Is that your only root? X equals this. What's the other one? What's the other one? If I have x equals 1 plus the square root of 7. X equals 1 minus the square root of 7. Good. And then you'd multiply together. Because you don't ever want to have i's in your polynomial, and you don't want to have roots. Okay, good? All right. It's very straightforward. If I were you, I would look over, I'd rewatch the videos, I'd look over homework problems, those sorts of things. If you have questions over the weekend, send me a screenshot. Don't try to write it in an email. I don't understand how to. Write a problem down, screenshot it, and email it to me, and then I can work it out and then send it back to you. Okay? Is that all right? Okay.